Good morning to all. Welcome to lecture 2 of module 4, Dynamics of Rectilinear and Curvilinear Translation. We already discussed section 1.1, which was Kinematics of Rectilinear Translation. In this video lecture, we will study 1.2, which is Kinetics of Rectilinear Translation. Now, before going deep into the subject, I request all my students to take this video lecture very seriously. Since I took these subjects a few times, coming to class and taking lecture is not that much hours of preparation is not required. But to create a video like this, putting animation and creating a video like this, it took almost one full day to create a video like this. Not only myself, all faculties are putting lots of effort and time to create a video lecture. So I request all my students to take this video lecture very seriously. Not only my subject, for all subjects, take the video lecture very seriously and study well. Okay. Now, coming to our subjects, kinetics of rectilinear translation. First, we have to study the equations of motion, which are Newton's second law of motion. The main equation of motion is Newton's second law of motion. We already know the Newton's second law of motion, F is equal to ma. Now remember that F and A are vectors. So you should remember like this. The vector F is equal to mass into vector A. Now you can split this vector equation into three separate equation, not different, separate equation. That is Fx is equal to max, Fy equal to may, and Fz is equal to maz, which means force in the equation 1 means the force in x direction is equal to mass into acceleration in x direction. Similarly, equation 2, force in y direction is equal to mass into acceleration in y direction, and equation 3, force in z direction sorry, force in z direction is equal to mass into acceleration in z direction. Now you should remember like this: force in a particular direction, not only simply x, y, or z. Force in a particular direction is equal to mass into acceleration in that direction. You should also remember a point like the acceleration in y and z direction has nothing to do with the force in x direction, since the force in x direction depends only on the acceleration in x direction. It has no relation with the acceleration in y or z direction. Okay. Now for a body, if a body is moving, it might have acceleration in only x direction. It may not have acceleration in y or z direction. So if it does not have acceleration in a particular direction, there is no resultant force in that direction, not just simply the force, no resultant force in that direction, but the body can have a motion in a particular direction and acceleration in that direction. Okay. Now while solving problem, you should again understand this concept. Okay, you should understand more about this concept. Okay. Now we will go to a simple problem. Question number 1: two bodies A and B of mass 80 kg and 20 kg are connected by a string and move along a rough horizontal plane under the action of force 400 Newton applied to the first body of mass 80 kg as shown in the figure. So that's the figure. Now the coefficient of friction between the sliding surfaces of the bodies and plane is 0.3. That mu is equal to 0.3 for all the surfaces. Now you need to determine the acceleration of the two bodies and tension in the string. You need to find out the acceleration of A and acceleration of B and the tension in the string. That blue line is the string connecting the two bodies, 80 kilogram and 20 kilogram. Now if you look at the figure, the left side of A, there is a force of 400 Newton is acting. Okay. Now you have to draw the free body diagram of A and free body diagram of B. Now if you look at the figure, the external force is acting in the left side. So the body A will move in the left side. since the body B is connected with A with a string, the B also move in the left side. Okay. Now, if you draw the free body diagram of A, the first thing is weight, vertical downward direction, which is WA. So mass is given 80 kilogram. So the weight of body A is 80 into 9.8. Now the external force of 400 Newton is acting, that is represented there. Then the tension in the string, is acting in the right side direction, as we already discussed in the module 2. The tension in the string is acting in the right side direction. Now since the body is moving in the left side direction, so first reaction provided by the surface on the body is there, that is Ra. Now since the body is moving in the left side direction, the frictional force provided by this contact surface will be in the direction right side direction, or in the direction in the same direction of tension, which is Fa equal to mu Ra. Now you have to remember one thing: the body is not in equilibrium. As I told in the video lecture 1, it is, we are studying dynamics. The body is in motion, it is not at rest. Okay, so the body is moving in the 400 Newton direction. Okay, but the frictional force will be there. Okay, this friction is actually not static friction, this is kinetic friction actually, but you can use the same equation mu Ra. Okay, now the direction in which body move is the left side direction. So the body, since the body is moving in that direction, it has acceleration in that direction, represented by A. Now you have to remember one thing: the direction in which body moves, that is the positive direction of motion. Again, the direction in which the body move, that is the positive direction of motion. So positive direction of motion means all the forces in that direction, you have to take all the forces in the direction of motion of the body as positive. All the forces acting opposite to the direction of motion, you have to take as negative. Okay, now we will draw the free body diagram of B. Now the weight of B, WB, again mass is given, so 20 into 9.8, and tension always away from the body, so T is represented in the left side direction, and the reaction provided by the surface on B, that is RB. And since the body is moving in the left side direction, the frictional force on B is same as that of same direction as that of A. So FB is equal to mu RB. Now again here again the body is moving in the left side direction. Okay, so A, acceleration A, which is again the positive direction of motion of body B. Now if you look at the acceleration value, whatever the acceleration value of A will be the same for the acceleration of B. Since the two bodies are simply connected parallelly with a string, the acceleration value of A will be same as acceleration value of B. Okay, now since now the free body diagram of A and B are completed, now we will go to solve the free body diagram using the equation of motion F is equal to ma in horizontal direction and vertical direction, and we will try to find out the acceleration of the body and tension A and T. Okay, now I am redrawing the free body diagram of A. Okay, A means left side body. I am redrawing the free body diagram here. WA 400 Newton, T and RA and mu RA. Okay, and acceleration direction A. Now from the FBD of A, Fx, I am taking the direction, positive direction of motion as the positive x direction. So Fx is equal to max. So here m is mass of the body A, so that's why I wrote ma in parenthesis into A. Acceleration of body A is small a. Now what all the forces in in the direction of A. So here the 400 Newton is in the direction of A. So 400 Newton is positive. T and FA is mu RA. T and FA are negative. Now the resultant force in x direction is equal to ma we already know 80, so 80 into a, so we will get this equation as 400 minus t minus fa equal to 80 into a. 80 is the mass of the body a and a is the acceleration. Okay, so you should remember that in module 1 2 we solve the equation, we solve the problem like resultant force in a particular direction is equal to 0, since in module 1 and 2 we were discussing statics where the body is at rest. Here you cannot use resultant force equal to 0 because resultant force never will be 0 because the body is moving. So if there is acceleration, since in this case there is x direction acceleration is there, so resultant force is equal to mass into acceleration. Okay, now you can substitute fa equal to mu ra in the equation, then we will get 400 minus t minus mu is already given 0.3, so 0.3 ra equal to 88. That is equation 1. Now if you take the vertical direction, that is resultant force in the y direction is equal to mass into acceleration in the y direction. Since there is no acceleration in the y direction, you can write resultant force in y direction equal to 0, since the body does not have any motion or component of acceleration in the vertical direction. Okay, so what are the forces in the y direction? Ra is the positive, Wa is negative, only two forces. So Ra minus Wa equal to 0, or Ra equal to Wa. Wa we already know 80 into 9.8, which is 784. It will coming as 784. Now if you substitute this Ra in equation 1, we will get 400 minus t minus 0.3 into 784 equal to 80a. Again if you simplify this equation, we will get 164.8 minus t equal to 80a. That is equation 2. Now in this equation 2 we had two variables t and a. So we only solved the free body diagram of A. If you solve the free body diagram of B, again we will get equation something like the equation 2, and since we had two equation and two unknowns, we can solve. Now I will go to the free body diagram of B. Now if you look at the free body diagram of B, the weight WB is acting in the downward direction and the tension is there, and the reaction provided by the surface RB and frictional force. Only four forces are there. Now acceleration in the left side direction, so A. Now resultant force in x direction is equal to mass into acceleration in x direction. So mass here mb, mass of the block B, and acceleration A. Now the x direction here, the positive, don't take t as negative because the positive direction is left side direction. Okay, don't stick the conventional xy direction. Okay, you have to follow the direction in which the body moves as the positive direction. Okay, so since a is in the left side direction, a is left hand direction, so t is positive, fb is negative. So we will get t minus fb equal to mass of block B is 20 into A. Clear? Now you can substitute fb equal to mu rb in that equation, then we will get t minus 0.3 rb equal to 20a. Now similar to the block A, here also the resultant force in y direction will be 0 because ay, the acceleration in y direction, equal to 0. Body is not moving in the y direction, there is no motion in y direction, body is moving only in the horizontal direction, so you can put ay equal to 0, no problem. Okay, so if you solve resultant force in y direction equal to 0, we will get rb as positive minus wb equal to 0, then we will get rb as equal to wb, which is 196. 196 means 20 into 9.8. Okay, now substitute ra in equation 3, we will get t minus 0.3 into 196 equal to 28. So t minus 58.8 equal to 28, which is equation 4. Now if you remember equation 2, which was 164 0.8 minus t equal to 88. Now we had two equation 4 and equation 2, and we had two variables t and a. So if you add this t equation, left side t get cancelled and right side we will get 100a. You can find out acceleration. So by adding equation 2 and 4, we will get 100 times a equal to 164.8 minus 58.8 is 106. So a acceleration is very simple, 106 divided by 100, which is 1.06 meter per second square. Clear? Now if we substitute the value of acceleration in equation 2, 4, 3, any equation, we will get the value of t. Now I am substituting this value of a in equation 2, but you will, sorry, equation 4, we will get, or equation 2 or 4, any equation, no problem, we will get the same values t as 80 Newton. Okay, so these two are the answer. Try to get this answer, try to solve, use the calculator, try to solve, and try to get these numerical values. Okay, now again I request all students, while watching this video, be ready with the pen, class note, calculator, and do the problems along with me. Okay, now we'll go to the next question. Is actually the next section, which is motion of body on inclined planes. Okay, we'll do a problem. Inclined plane, the plane in which the body move has an inclination with a horizontal axis, that is the inclined plane. So how will you solve the dynamics in an inclined plane? It's again the same idea. We are using the same force in a particular direction is equal to mass and acceleration in that direction, the same idea. So we will do a problem and we will understand what is this inclined plane surface problem. Okay, now a body of mass 200 kilogram is initially stationary. You should again read that sentence, initially stationary on a 15-degree inclined plane. What distance along the inclined plane the body must slide before it reaches a speed of 10 meter per second? Take coefficient of friction between the body and the plane as 0.1. Okay, so sometime the university will give the figure, sometime they won't, simply give the question. So here figure is something like this, horizontal direction, there is an inclined plane which is 50-degree with the horizontal, and there is a body. So the body initially stationary, and we are dropping, or we are just placing that body there. So since it is inclined plane, the body will slide. Now remember that the body is not at repose condition, or body is not stationary there, body will slide. Okay, and you need to find out how much distance the body move before it reaches the velocity 10 meter per second. Okay, so this problem you cannot solve using the equation of motion, which are the equations of kinematics. V square equal to u square plus 2s, v equal to s is, v equal to u plus at, s is equal to ut plus half at square. Only using that equations you cannot solve this problem. Then why? Here the body starts from rest, u equal to 0. You need to find out you need to find out the displacement s. V is given, v equal to 10 meter per second is given. Okay, so u equal to 0, v is 10. Now how will you find out displacement? So if v and u are given and nothing mentioned about the time, the only equation you can use is v square equal to u square plus 2a. But in that equation you should know the value of a. You cannot take g or component of g here, because the body is not simply sliding on a smooth surface, it is sliding on a rough surface. The coefficient of friction is given. So you should know the value of acceleration to find out the displacement. So in order to find out the acceleration in this problem, you should do the kinetics analysis, not only the kinematics analysis. Okay, clear? Now we will draw the free body diagram of A. So a plane which is at an angle 15 degree, and the body A. So weight vertical downward direction WA, and you can split that weight or resolve that weight into two components. Before splitting, there is a reaction force provided by the surface on the body A, RA. Now you can split WA sin theta, WA cos theta and WA sin theta. Here theta is 15 degrees, so WA cos 15 degree in the in the perpendicular direction of the plane, and WA sin 15 degree in the parallel direction of the plane. Okay, so once you split WA into WA cos 15 and WA sin 15, you should not represent WA. That's why I use blue color for WA. Okay, the forces, all the forces acting on the body, I will represent it with red color. Okay, now since the body is sliding down, the frictional force, the direction of frictional force will be right side direction, FA. So yeah, the body is moving in the or sliding downward direction, so that is the direction of acceleration. Now frictional force will be in the opposite direction, which is Fa equal to mu Ra. Now you know the direction of acceleration. Now all the forces in the direction of acceleration, which is represented by that blue thick line, all the forces in that direction you should take as positive, and all the forces in the opposite direction you should take negative. Okay, and there is no acceleration in the vertical direction of the plane, only acceleration in the parallel direction of the plane. Okay, so the direction of acceleration is the positive direction. Now here it is given mass of the body A. So it is 200 kilogram. So WA is simple, 200 into 9.8, and mu is given 0.1. Now from the free body diagram of A, you will get resultant force parallel to the plane will be mass into acceleration parallel to the plane. So mass of body A is ma, and acceleration of body A is simply A. This is not a connected body problem, it is only single body problem. So A. Now what all the forces you should take positive? WA sin 15 degrees positive and FA is negative. Only two forces are coming in the direction of A. So WA sin 15 degree minus FA is mu Ra equal to mass of A is 200 into A. Clear? Now WA is coming as 1960. So substitute that value here. Then 1960 sin 15 degree minus mu is given 0.1 Ra equal to 200 A. That is equation 1. Clear? Now the resultant force perpendicular to the plane will be 0. Why? Because there is no acceleration perpendicular to the plane, since the body does not have any motion or component of acceleration in the perpendicular direction. Okay, so what are the forces in the vertical direction? Ra and WA cos 15 degree are the vertical direction. Ra is positive, you can take Ra as positive, so Ra minus WA cos 15 degree equal to 0. So you will get Ra as WA cos 15 degree is coming as 1893 Newton. Try to get that value using calculator. Okay, now you can substitute this Ra in equation 1. What you will get? 1960 sin 15 degree minus 0.1 into 1893 equal to 200 A. So you can simply solve and you will get the value of A as 1.59 meter per second square. Now we got the value of acceleration of A. Now in the question, it is not asked to find out acceleration. Actually you need to find out the displacement along the plane, right, where the body must slide before it reaches the value of velocity as 10. So you can take U as equal to 0, since the body is initially starting from rest or initially stationary. So assume it's not actually assume, you can take initial velocity U equal to 0 and V equal to 10 meter per second. You need to find out S. So you can use V square equal to U square plus 2S. So we will get V is 10. So 10 square equal to 0 plus 2 into A. We already know 1.59 into S. So we will get the value of S. Simply solving that equation, we will get the value of S as 31.4 meter. So this much distance the body will slide along the plane before reaching the value of velocity as 10 meter per second. Okay, it's a very simple problem. Okay, now going to the next section, motion of connected bodies. Okay, connected body means uh, more than one body or two or more bodies are connected by string or spring, and a motion of one body result in motion of the other bodies. Okay, now again remember that we are studying dynamics. So in connected body, all the bodies are in motion. Okay, now this one is an example where a body A is connected to the body B by pulley and string. Okay, now if you look at the figure, the body B is not in contact with the surface. It is it is free, and it will move in the downward direction. So since because of the motion of body B in the downward direction, the body A will move in the right hand direction. Okay, now since the body A is sliding motion, there will be frictional force acting on body A. There is no frictional force acting on body B. Sorry, since the body B is free. Okay, free from contact surface, not entirely free. It is connected with a string. Now if you look at the second figure, the body A is connected with the body B using two pulleys. Okay, here again the body B will try to move in the downward direction, or will move in the downward direction, and because of the motion of body B in the downward direction, the body A will move in the right hand direction. Again the body B is not connected or not in contact with any surface. Okay, now in figure 1, the acceleration of body B is in the downward direction, its value is A. The same value of acceleration happened to the body A. Body A has acceleration small a. So the magnitude of acceleration of body A and B in figure 1 is same. Its value is A. And the positive direction of B is downward direction, and positive direction of A is the right hand direction. Okay, since the acceleration in that direction. Okay, now if we look at the figure 2, the acceleration of body B is in the downward direction, and acceleration of A is in the right hand direction. But the value of acceleration of B and value of acceleration of A is different. Okay, play attention to this figure 2. Pay attention to this figure 2. So we represent acceleration of body A as AB. Sorry, the acceleration of body B as AB, and acceleration of body A as A suffix A. Now why it is different? Okay, for that I am taking the distance from body A to the pulley. So the pulley 1, the first pulley is a fixed frame. The second pulley, the pulley near to the body B, is not a fixed pulley. It will move in the downward direction. But the first pulley is a fixed frame. So I am taking that distance as x, and the distance of the pulley near to B to the fixed frame as y. Okay, now while body B is moving in the downward direction, both x and y will change. X will increase, y also will, x will decrease, y will increase, right? But the total length of the string, what will be the total length of the string? It will be x plus y, 2y, right? So the total length of the string L equal to x plus 2y, right? The total length of the string will be x plus 2y, which remains constant. The string length is not changing. Okay, you should remember the length, the total length, not simply length. The total length of the string is not changing, which is always x plus 2y, which is constant. But the value of x will change. It is something like the amount x decreases, there will be increase in y, such that x plus 2y remains constant. Okay, so while the motion of block B, x and y will change with respect to time. So we differentiate this equation 1 with respect to time, we will get during the motion of block B, x and y will change, total length remains constant. So while differentiating this length L with respect to time t, we will get d by dt of x plus 2y equal to 0. Now again, if you differentiate, if you rearrange, dx by dt plus 2 into dy by dt is 0. Now what is dx by dt? Dx by dt is actually the velocity of block A, right? X is the displacement of block A from a fixed frame, and y is the displacement of block B from a fixed frame, right? So dx by dt is actually VA, and dy by dx by dt is VA, and dy by dt is VB. So we will get VA plus 2VB equal to 0, right? From this equation you can see velocity of A is minus 2VB. If you take the magnitude, VA is 2 times VB, right? That is, the block A move twice speed of block B. It is not in the same in the case figure 1. Figure 1, velocity of A and velocity of B are same. Acceleration of the block A and acceleration of block B are same. But in figure 2, the velocity of A is 2 times the velocity of B. It is because of the arrangement of that pulley. Okay. Now, if you differentiate the equation again, we will get d by dt of VA is acceleration of block A. So acceleration of block A plus 2 times acceleration of block B equal to 0. So you should remember the magnitude wise, you should remember, you don't have to remember the negative sign. Why there is negative sign? It is something like the x is decreasing, right? So if you take that positive direction of x, the positive direction, in positive direction x is decreasing, so velocity of A is negative, and if you take the positive y direction, positive direction of block B, y is increasing. So in one case the displacement is decreasing, in the other case displacement is increasing. That's why negative sign is coming. So you should not go or you should not stick more into the negative, but you should remember the magnitude of acceleration of B is half of acceleration of A, like that you remember. Okay, so the acceleration of B, acceleration of block B is half the acceleration of block A. Or try to remember like this. Okay, the block B is connected with two string, right? The block A is connected with only one string, so the block B is connected with two string. So if a block, try to remember like this, if a block is connected with two string, its acceleration is 1 by 2 of the acceleration of the block which is connected with one string. Okay, so if a block is connected with a two string, its acceleration is half of or 1 by 2 of the acceleration of the block which is connected with the one string. Okay, try to remember like that. Okay, so these connected body problems are asking in the university questions. So you should remember this, the final equation, acceleration of B equal to 1 by 2 of acceleration of A. And you should remember like this, if a body is connected with two string, its acceleration will be low value, okay, compared to the block which is connected with only one string. Okay, okay, now we will look at the free body diagram. Okay, free body diagram of figure 1 and figure 2. Okay, now look at the free body diagram of figure 1. In block B, the weight is in the downward direction, so WB, and tension in the upward direction T. Okay, and positive direction of block B is in the downward direction, so WB is positive, T is negative. Okay, now if you look at the free body diagram of A, tension is in the direction, right hand direction, and T, and weight WA downward direction, and the reaction provided by the surface RA, and since the body is moving in the right hand direction or in the direction of T, the frictional force in the opposite direction, Fa equal to mu RA. That is the free body diagram of figure 1. And go to the figure 2. WB is in the downward direction, and in for the block B there are two T's acting. Okay, one T is in one string and the other T is in the next string. So, and in net effect there will be 2T acting on block B. That 2T is balanced, not balanced, 2T in the opposite direction and WB is in the downward direction. So here positive is WB for the block B, the positive direction is WB, and the negative direction is not simply T, 2T is in the negative direction. Okay, now look at the free body diagram of A in figure 2. T is in the right hand direction. Its free body diagram is same as in the figure 1. WA is in the downward direction, RA is in the upward direction, and the frictional force in the opposite direction. Okay, now we will try to have more examples of the connected bodies. Okay, you can have an inclined plane also, a connected body system. Okay, here the block A is in an inclined plane, the block B is free from the surface, and here in the second figure the block block A is in the inclined plane, block B is connected by two pulleys or two strings. Okay, in figure 3 and figure 4, if you look at the figure 3, for figure 3 acceleration of A is equal to acceleration of B, but in figure 4 the acceleration of B is half the acceleration of A. Okay, as I discussed in the previous slide, here B is connected with the two string. Okay, now if you draw the free body diagram of B, WB downward direction, T upward direction. Again for A, T is in the direction of string, and RA in the direction perpendicular to the plane, and WA is in the always in the vertical downward direction, and frictional force in the opposite direction of T for figure A. Now if you look at the free body diagram of B, WB in the downward and 2T is in the upward direction, and T is in that direction of string, and the free body diagram of A is same as in the figure 3. Okay, RA and FA is in the opposite direction. Now which direction the body B moves in figure 3? In the downward direction. It will try to move in the downward direction. Okay, and if it is moving in the downward direction, and the WA is moving the direction as shown in the figure. Okay, similar in figure 4, the block B will try to move in the downward direction, so that is a positive direction, and block A is moving in the direction as shown in the figure. Now you should pay attention that in figure 3 and figure 4 there can be a case where the body A is on a smooth inclined plane. Smooth inclined plane means Fa is not there, mu is 0. Okay, smooth inclined plane means mu equal to 0, and Fa, the frictional force provided by that inclined surface, is 0. Okay, so what happens if the frictional force is 0? So if the frictional force is 0, again it can have motion. The block B can move in the downward direction, and block A move in the upward direction along the plane. Okay, if weight of the block A or the component of weight in the plane parallel to the plane is more, then WA may move in the downward direction, and block A will move in the downward direction, and block B will move in the upward direction, right? So inclined plane, the motion of connected bodies in inclined plane can have problems without friction also. Okay, we will try to do one problem with the friction and one problem without friction. Okay, then we will wind up this section of motion of connected bodies. Okay, so we will go to the problem, numerical problem. Okay, so now two blocks of mass 50 kilogram and 40 kilogram are connected by a string as shown in the figure. Yeah, it is the figure. then you need to find out the first principle means from the first principle means from Newton's second law, actually a physical domain. You need to find out the acceleration of the system and tension in the carbon. Accelerations of the system means you need to find out the acceleration of both the blocks. Okay, and you need to find out the tension. The tension in the string will be always T. Okay, don't take T1 T2 as I discussed in the module 2. Don't take T1 T2, always T. Okay, single letter T, and you can take mu equal to 0.3. So it's already given in figure that 50 kilogram is the block is connected with one string, and 40 kilogram block is connected with the two string. Now we can draw the free body diagram. Okay, I am taking 50 kilogram as A, block A, and 40 kilogram as block B. Okay, now if you draw the free body diagram of B, the WB in the downward direction and 2 T's in the upward direction. Okay, and WA in the downward direction for the block A, and RA in the upward direction, and now we can assume that the block B is moving in the downward direction. It's not like assume, the block B will move in the downward direction, so the block A will move in the right hand direction. Okay, so the frictional force in the left hand direction and T is in the right hand direction. Now the block B will move in the downward direction, so that is the acceleration of block B, which is the positive direction, and block A will move in the right hand direction, which is the positive direction for block A. So for block B, WB is positive, 2 T's are negative, and for block A, T is positive, FA is negative. Clear? Now acceleration of block A and acceleration of block B will be different, since the block B is connected by two strings, or is in net effect it is connected with 2T, or there is 2T force acting, but for block A there is only T is acting. Okay, so we already know acceleration of block B is half the acceleration of block A. Okay, since the block B is connected with the two strings. Okay, now if you take the free body diagram, or from the free body diagram of block B, we can write WB is positive, 2T is negative. Okay, so resultant force in the direction of acceleration, resultant force is equal to mass into acceleration. So WB minus 2T equal to mass of block B in the acceleration of block B. You should not simply write A, you should write A suffix B. Okay, acceleration of block B. So WB we already know, WB is 40 kilogram into 9.8, right? 40 into 9.8. So WB is 392 Newton. So if you substitute there, 392 minus 2T equal to mass of block A, we know 40 kilograms. So 40 into acceleration of B. So that is equation 1. Okay. Now if you take the free body diagram of A, okay, free body diagram of B is over. There is no other forces acting in block B. Now if you take the free body diagram of A, here there are forces in the horizontal direction and vertical direction, but the body move only in the horizontal direction, so resultant force only in the horizontal direction. So first I am taking the resultant force in the vertical direction. So what is the resultant force in the vertical direction? It is 0. Why? Because acceleration in the vertical direction, or in the vertical to plane, is 0, right? So we had RA positive and WA negative. So RA minus WA equal to 0. Why it is 0? Because resultant force in the vertical direction is 0. Okay. So basically we what we are getting is RA equal to WA. WA we know mass is 50 into 9.8. So 490 Newton. Okay. So we got the value of RA. Now I am redrawing the free body diagram of A here again. Okay. It is same as in the previous slide. Now resultant force in a particular direction is equal to mass into acceleration in that direction. Now T minus mu RA. So T is positive, right? Since T is in the direction of acceleration, mu RA or FA is in the opposite direction. That's why T minus mu RA equal to mass of the block A into acceleration of block A. So MA into A. What is MA? MA we know, this is parallel. MA we know 50 kilograms. So T minus mu is given 0.3. So 0.3 RA we already found out using the vertical or perpendicular to plane, or in the previous slide we already found out the value of RA, which is 490. Substitute the value of mu and RA, we will get T minus 0.3 into 490 equal to 50, right? So if you again simplify that equation, we will get T minus 147 equal to 50 into acceleration of A, which is equation 2. So if you remember the equation 1, I am rewriting the equation 1 here, which is 392 minus 2t equal to 40 AB. Okay, or you can go to the previous slide. You can go back to the video. You can see equation 1 is 392 minus 2t equal to 40 AB. Okay. Now in equation 2 there 2t is single t, and equation 1 there is 2t. So there are two variables t and aa. Actually there are three variables t, aa and ab. Now to remove I am multiplying equation 2 with number 2 or numerical 2. Okay, so equation 2 into 2 we will get 2t minus 147 into 2 equal to 50 into 2, that is 100 aa, right? So 2t minus 147 into 2 is 294 equal to 100 into acceleration of A. Now if you add the equation 1 and 3, if you add the equation 1 and 3, what you will get? 2t get cancelled, one is plus and other is minus, and 392 minus 294 you will get, 392 minus 294 equal to 40 AB plus 100 AA, right? So we will get, and if you divide with the 10 you will get 9.8 equal to 4 AB. I am minusing 392 minus 294 is 98. I am dividing with the 10. You can do in your own way, no problem. So 9.8 equal to 4 AB plus 10 AA. Now how will you solve this equation? Okay, we already took all the forces, all the possible equations of motion. F is equal to ma. Finally we are getting equation 4. Now how will you solve the equation 4 to get the acceleration? For that purpose we already know, as I discussed in the previous case, we already know acceleration of B equal to half the acceleration of A, right? So substitute this equation in equation 4, we will get 9.8 equal to 4 times AB. I am substituting as half AA. So 4 into 1 by 2 AA, you will get 2 AA plus 10 AA, right? So it will be 12. So 9.8 is equal to 12 AA. So we will get acceleration of A is 9.8 divided by 12, which is 0.82 meter per second square. Now if we substitute this, or we already know acceleration of B, the block B is half of acceleration. So half of this value will be the acceleration of the block B, which is 0.41 meter per second square. Okay, so we got the value of acceleration of block A and B. Now if you substitute the value of this acceleration in any of the equation 1, 2, 3 or 4, we will get the value of tension. Sorry, in equation 1, 2 or 3. 4 there is no tension, T is there. So you can substitute in equation 1 or in equation 2. I am simply putting in the equation 2. What you will get? T minus 147 is equal to 50 into AA. Remember, in equation 2 the acceleration is AA. In equation 3, in equation 1 it is AB. Okay, so 50 into 0.82. Now we will get the value of T as 188 Newton. Okay, now try to get this value. Okay, it's very simple and straightforward question actually. Okay, now we will go to another question. Okay, system of bodies shown in the figure which starts from rest. Determine the acceleration of body A and the tension in the string supporting the body B. Okay, so it's an inclined surface. So this figure is different than the figure I previously discussed. Okay, in the figure I discussed in the previous case, block A is connected with only one string. Block B is actually connected with the two string. But in this case, the block A is connected with the 2 string and B is connected with only 1 string. Okay. Now, the inclination is given like 4 3. So we already solved this kind of problem with the inclination given like 4 3. Okay. Now, 750 Newton, the weight of A and B is given as 750 Newton and 500 Newton. So don't take it as mass, it is weight is given. Okay, WA and WB is directly given as 750. You can find out MA. How will you find out? The WA divided by G. Okay, that is MA, and MB is WB divided by G. Okay. Now we'll go WA is given, the value is 750 and WB is 500 Newton. Now I am redrawing the figure, and the angle theta we don't know right now. Okay, but it is given as 4 3. So what is tan theta? Tan theta is simply 3 by 4. So you can find out theta, which is tan inverse 3 by 4, we will get as 36.87. It is actually degree, I forgot to put degree there. It is actually theta equal to 36.87 degree. Okay. Now the body B. Okay, before going to this problem, if you observe the question, there is nothing mentioned about the friction, right? The friction value is not given, mu is not given. So this problem you can solve without considering the friction, without considering Fa for the block A. Okay, so Ra will be there. Ra is not 0, mu is 0, that's why Fa equal to 0. Okay, don't take Ra as 0. Okay, Ra is there, the reaction provided by the surface on A is there, mu is actually 0, that's why Fa equal to 0. Okay, now you can assume. Now one more thing, in this case there are two possible motions. One, the block B move in the upward direction, or A sliding down along the inclined plane. That is one case. The other case is block B move in the downward direction, or block A is going up along the plane. Okay, so which direction we will take? Okay, so you have to follow like this. You can assume any direction for block B. Okay, so once you select, or once you assume a direction for block B, based on that direction of block B, you should take the direction of A. Okay, it is not like block B moving downward direction and block A moving down or sliding down, which is not possible, right? If block B is moving the downward direction, the block A has to climb up, right, or moving up direction. Or you can take block A moving downward direction. If block A is moving downward direction, block B has to move upward direction. Okay, for this case I am taking the direction of block B, or assuming the direction of block B as downward direction. So downward direction block B is moving, so that direction is the acceleration, that is AB, acceleration of block B. Now remember, if I am getting the value of AB as negative value, okay, negative value if I am getting, what will be the inference? The inference is the direction I took was not correct, right? Was in the opposite direction the body moved. The body moved in the direction opposite to the direction I took. Okay, so finally I can write like since acceleration value is negative, it's not like value negative, I am getting the sign of acceleration as negative. The direction I took, the body move in the direction which is opposite to the direction I took. Okay, like that you can write, which is not it is not like the direction you take is wrong. It is not like that. Finally you have to write like the body move in the direction opposite to the direction of assumption. Okay, that's the corrective method. Okay, so in this case you cannot say which body will move in the downward direction and which body will move in the upward direction. So we have to start with an assumption. Okay, so the assumption is body B is moving in the downward direction. Since the body B is moving in the downward direction with AB, acceleration of A in the upward direction, so AA. Okay, Now again AA and AB are different, right? Now if you complete the free body diagram of B, WB in the downward direction, T in the upward direction, and WA is in the downward direction, and WA you can split into WA sin theta and WB cos theta. Actually we know the value of theta, but I write WA sin theta and WA cos theta. And RA, there is RA, okay. In this case we are not considering the friction, so there is no mu RA, only RA is there, okay. Now for block B there will be T, and for block A there will be two T's acting, right? There are two strings are there, so two T's are there, okay. Now we are assuming the body A moving in the downward direction, okay. Now acceleration of A will be half of the acceleration of B, right? Acceleration of block A will be half of the acceleration of block B. Why? Because the block A is connected with the two strings. So acceleration of A is half of acceleration of B. In the previous case, it is like acceleration of B is half of acceleration of A. But here A is connected with the two strings. So we have to write acceleration of A is half of the acceleration of B. Now if you take the free body diagram of B, which is WB is positive, remember WB is positive since AB is in the downward direction, okay. So WB minus the resultant force is equal to mass into acceleration. So WB minus T equal to mass of B into AB. Now what is the mass of B? Mass of B we know that 500 is the weight, divided by 9.8 we will get 51.02 kilogram. So we WB we know 500, okay. Don't confuse with the WB with the MB, okay. WB is given 500 minus T equal to 51.02 into AB, okay. Now from the free body diagram of A, if you take the vertical to the plane, okay, vertical to the plane there is no acceleration, so resultant force is equal to 0. So what you will get? RA minus WA cos theta, okay, not simply WA, remember that it is the component of WA which is balanced by RA, okay. Here you can say balanced because the resultant force is equal to 0, okay. So RA minus WA cos theta equal to 0. From this equation, vertical plane, from this equation you will get RA because WA we know, theta we know, okay. So we will get 600 Newton as RA, okay. Now I am redrawing the free body diagram of A here, okay. Now resultant force is equal to mass into acceleration. So 2T is positive and WA sin theta is negative, and equal to mass of body A into acceleration of body A. Okay, it is parallel to plane. So 2T minus WA we already know 750 into sine 36.87 equal to MA into AA. Now MA is 750 divided by 9.8, which is 76.53. So 2T minus 450 equal to 76.53 into AA, which is equation 2, okay. So if you remember equation 1 which was 500 minus T equal to 51.02 AB. Now equation 1 has to multiply with 2, right? Because equation 2 there is 2T. So I multiplied equation 1 with 2. So 1000 minus 2T equal to 102.04 into AB. Now if you add equation 2 and equation 3, we will get 1000 minus 450 equal to 102.04 AB plus 76.53 AA, right? So which is 550 equal to this value. Now like in the previous case we know acceleration of B, you can substitute that acceleration of A is half the acceleration of B. Substitute in this equation 4, we will get 550 equal to 102.04 AB plus 76.53 divided by 2, which is 38.265 AB. Now if you rearrange this thing, we will get the value of AB as 3.92 meter per second square, and since AA is half of that AB, then AA is 1.96 meter per second square. So we got the value of acceleration. Now if we substitute this value in equation 2 or in equation 3, I am substituting in equation 2, which is 500 minus T sorry, yeah, I am substituting actually in equation 1. It is not equation 2. Equation 1, we will get 500. You can substitute in equation 2 also. You will get the same value of t. I am substituting in equation 1. 500 minus t equal to 51.02 into 3.92. Then we will get the value of t as 300 Newton. Okay. Now try to get this value. Try to solve it. Okay. Now we'll solve one more problem and we will wind up this section of kinetics of rectilinear translation, and we will discuss kinematics of rotation motion in the next video. Okay. Now we will solve a simple problem. Determine the tension in the string and acceleration of two blocks of mass 150 kilogram and 50 kilogram. So it's actually given 150 and 50 kilogram, which is connected by a string and a frictionless weightless pulley as shown in the figure. Okay, you need to find out the tension and acceleration of the block. Okay, it is very simple question actually. Okay, so here both the blocks A and B, so both the blocks A and B are not in contact with any surface. There is no friction there. Only T and weight is acting on the body, and the body is moving. Okay, now if you draw the free body diagram of block A, I am putting as 50 kilogram mass as block A, and the other one is block B, and I am assuming the block B is moving in the downward direction. Okay, which is a reasonable assumption because block B has more weight or more mass than block A. So I am assuming, like I said, discussed in the previous case, if suppose I am getting a B as negative, then my assumption was wrong, and I can write like the body B move in the opposite direction of the assumed direction. Okay. So AB is in the downward direction and AA will be in the upward direction. You cannot take A, block A is also moving in the downward direction, which is wrong. That assumption, not, it is not actually assumption. That direction, selection of that direction is wrong. Okay, so you should take acceleration of A or the motion of A as in the upward direction. So you can simply look at the pulley system. Okay, so if body B is moving in the downward direction, what will happen to body A? It will move in the upward direction. By simply looking at the block, sorry, the figure, you can tell the direction of A if B is moving in the downward direction, right? So if body B is moving in the downward direction, the pulley connected with the body B will move in the downward direction. So body B obviously will move in the upward direction. Okay. Now the downward direction is the positive. So the direction of AB is the positive direction of block B or body B, and the direction of AA is the positive direction for the block A. Okay, so it is not the traditional positive negative direction in dynamics. Okay, that's a important concept in dynamics. That is, which direction body move or assumed to move is the positive direction. Okay, so all the forces in that direction is positive. Okay, now the WB is in the downward direction and 2T's are in the upward direction, and for A, WA is in the downward direction and T is in the upward direction. Okay, now WA is, you can find out because mass of body A is given, so 50 into 9.8, which is 419 Newton, and WB is 150 into 9.8, 1470 Newton. Okay, now acceleration of the block B is half the acceleration of block A. Why? Because the block B is connected with the two string, its acceleration is half of the acceleration of A, right? We already discussed this idea in the previous slide. Okay, now assume the block B move in the downward direction as I shown in the figure. Okay, now take the free body diagram of B. So if you take the free body diagram of B, WB is positive, right? So WB minus 2T equal to MA. MA is mass of block B into acceleration of block B. WB we know the value 1470. So 1470 minus 2T equal to mass of B is, we know, 150. So 150 into AB. Okay. Now from the free body diagram of A, T in the positive direction, right? T minus WA equal to MA, mass of A into acceleration of A. Okay, so T we don't know, so T minus WA we know 490 equal to mass of A we know 50 AA. That is equation 2. Now that equation you have to multiply it with 2, because in equation 1 there is 2t, so I multiplied, then we will get 2t equal to 490 into 980 equal to 15 into 108. So now equation 1 and 2, if you add equation 1 and 2, t get cancelled, right? So what we are getting is 1470 minus 980, which is 490. 490 equal to 150 ab plus 100 aa. Okay, so don't forget to put the suffix ab, sorry, b for acceleration of block b is a suffix b, acceleration of block a is a suffix a. Okay, if you forget to put the suffix b, a and b, then we will you will make a mistake that 150a plus 100a is 250a, and you will find out, you will get the value of a, but it will be wrong. Okay, now you have to substitute AB equal to half AA in equation 3. Okay, substitute AB equal to 0.5, half means 0.5 AA in equation 3. You will get 490 equal to 170 AA. Then you can simply find out AA, which is 2.8 meter per second, and you can find out AB. AB is half of AA, which is 1.4 meter per second square. Now if you substitute AA and AA or AB in any one of the equation, you will find out the value of T. So I am substituting AA in equation 2. What I am getting is 2t equal to 980 plus 100 into 2.8, which is 630 Newton. Okay, that's all. And that's all this question, which is a very simple question. You need to find out acceleration of the blocks and tension. Okay, so that's all about the section 1.2, which is kinetics of rectilinear translation. Okay, in this section 1.2 is very important in the university point of view. Normally they will ask a question of connected body or simply inclined body in the university. Okay, now try to solve all the problems as given in the PDF file, and try to solve all the problems in the textbook, Benjamin textbook. Okay, if any doubt, just call me or mail me, and in the next session we will solve the kinematics of rotational motion. Okay, thank you for listening the video.